What is electric charge? Electric charge. Any matter whatsoever, it contains fundamental particles. These are more than 100, fundamental particles are more than 100. And out of them, 3 are of prime importance to us. One is electron, then proton, and then neutron. So if this is a nucleus, it contains proton, it contains neutron. It's a neutron is neutral, and then outside in orbit we have electrons orbiting. Because of the masses of these particles, they exert gravitational force. We know there is a gravitational force always. For example, 2 electrons, if they are kept 1 centimeter apart, they exert 5.5 into 10 to the power minus 67 Newton gravitational force on each other, which is attractive. Gravitation force is always attractive. But an electron is found to repel another electron. So what is this force? Why this repel or repulsion is going on? If you keep it at a distance of 1 centimeter, the force would be 2.3 into 10 to the power minus 24 Newton. This is the force by which these 2 electrons, they repel. So what is this additional force? There is a gravitational force we talked about, but there is another force which is known as electric force. The fundamental intrinsic property due to which this force acts is because of the charge of this electron, because of the electric charge. So as the masses, we know that the force, gravitational force, is given by m1, m2 by the distance square, and of course we have a gravitational constant g. Since masses are playing a role here in the gravitational force, the charges are responsible for the electrical force. If you do the same activity with proton, that is 2 proton, if they are placed at 1 centimeter, they will repel with the same force, 2.3 into 10 to the power minus 24 Newton. Right? That means proton also has electric charge, and the magnitude is exactly same as the electron, the forces between the 2 electrons. Now if you do something else, if you put a proton and now an electron, and you keep them say 1 centimeter apart, then what happens? Again they exert this much of force, same force on each other, but now the force is attractive. Between electron, between proton, the force is repulsive, but here the force is attractive. So what we conclude here is the magnitude of charge on electron and proton is same, but they are opposite. That is why I am putting plus here and negative here. So electric charge are of 2 types, positive charge and negative charge, and traditionally we have considered this proton as positive and electron as negative. It makes no difference, but we'll see and we'll follow this convention for our next discussions. The force which is acting between 2 like charges, like the proton and proton, they are repulsive. Electron and electron, repulsive. But a proton and electron, they are attractive. So all material bodies, they contain equal number of protons and electrons in their normal state. That is, they are electrically neutral at this time, right? But the electrons, as I just showed you, electrons are outside, because this is the nucleus. Electrons are outside, so there is some outermost orbit where always some electrons are present, and they are moving, they are orbiting. So whenever there is an exchange of charge between 2 bodies, say because of the friction, these are loose electrons, and they will transfer from one body to another. Say if you take a glass rod and if you rub it with a silk cloth, some of the electrons from the rod will get transferred to this silk cloth, and the glass rod will become what? Because the electron has transferred from glass rod to the cloth, glass rod will become positively charged because the electron has gone to cloth. In the same way, the cloth will gain some electron and it will be negatively charged. In order to detect these charges, we have a very simple device which is known as electroscope. We call it as a electroscope. So electric charge is a fundamental property, just like mass. Just like mass, the charge is also electric property. And the SI unit of this charge is coulomb. We'll abbreviate it with C, capital C. So what is a coulomb? A coulomb is a charge which is flowing through any section of the conductor in 1 second when the electric current now is 1 ampere. So the charge on proton is this one, 1.6 into 10 to the power minus 19 coulomb, and the charge on electron will be same value with a negative sign, minus 1.6 into 10 to the power minus 19 coulomb.